Let's consider this curve f of x equals x cubed minus 3x squared plus 2. And we're going to find the derivative at x equals a. Notice this time we're not putting in a number for a. We're going to find an equation for the derivative so that we can find the derivative at any point for whatever x we want, any point on that curve. So that curve is a cubic polynomial, so it looks something like this. And now, if I get an equation, that means I'll be able to find the slope at any point. So it'll give me a lot of different slopes. Okay, so let's find that general equation. So the derivative can be found with two different formulas, but we're just going to pick one. So the derivative at a equals, so depending on which definition you want to use, you could either use the one where x goes to a, or you can do h going to 0, where h is the distance between x and a. You could use either one. They'll both work beautifully in this problem, but it's really just up to you. So that definition is f of a plus h minus, or the definition is the limit of f of a plus h minus f of a all over h, taking that limit of h as h goes to 0. Now I want to plug in the function we have here, so I'll take the limit as h goes to 0, and I want to plug in, for the first part of the numerator, I'm plugging in the a plus h into these x values to rewrite this function of f of a plus h. So that is, for x cubed, I do a plus h cubed, quantity cubed, and then I plug it in for the next x, and I get minus 3 times a plus h quantity squared. Make sure you're using parentheses so you have the whole quantity being cubed and squared, and plus 1 at the end. And then for the second half of the numerator, I have f of a, so I'm going to plug in an a for those x's. So that gives me a cubed minus 3a squared plus 1. Notice this minus sign between the two functions. I'm going to put that minus sign, and I have to put parentheses around this whole second function. Try not to distribute that negative as you're writing it the first time, because it's such a common mistake to make a sign error while distributing and writing the function at the same time. So save that for its own step. All right, so this equals the limit as h goes to 0 something over h, and now I'm going to try to simplify this numerator. So a plus h cubed is really a plus h 3 times. Remember, it's the quantity of a plus h cubed. So you have to use that a plus h, a plus h, a plus h. That's different than a cubed plus h cubed. And then I have a minus 3. I want to distribute in there, but I can't do that just yet because it's got an exponent. So exponents first. So I'll do a minus 3, and then I do this exponent, so a plus h, that's really a plus h times a plus h, or it's a perfect square binomial, so I can write that as a squared plus 2ah plus h squared. Okay, and then I have the plus 1, and I have minus a cubed minus, I'm sorry, you know what, I almost made my own mistake. So I want to distribute this negative, so make sure that goes to every one of those terms while I get rid of those parentheses. So I get minus a cubed plus 3a squared minus 1 all over h. All right, simplifying that a little further. So the numerator is, the denominator is just h. The numerator, I want to simplify it a little further, so I'm going to try to, I'm going to combine these two parentheses first. I'm going to FOIL these. So I can do a FOIL, or I can just recognize that as also a perfect square trinomial, the same one we just did in the second term on the step above. So I'll have a plus h, and then a plus h times a plus h gives me a squared plus 2ah plus h squared. And then I want to distribute the -3 to each one of these terms. Don't forget the negative on every step. It's a really common mistake to miss a negative, and then it makes your whole problem wrong. It's a long algebraic process, so you don't want to make a small sign error in the middle of it, so be very careful. And then we have plus 1 minus a cubed plus 3a squared minus 1. All right, my next step, I'm just going to keep reducing here. Now I'm going to distribute my a plus h into this perfect square trinomial. So first I'll start with the a's and distribute my a to each one of those. So I get a cubed plus 2a squared h plus a h squared. And then I do the h and distribute to each of those. And I have a squared h plus 2ah squared plus h cubed. And then the rest of the numerator is already distributed, so I can just write it down. Now, as I go, I can actually sometimes catch some things I can distribute right away, like plus 1 and minus 1. I know those are going to cancel, so I don't really have to, I can cancel them now, and I have a little less to write in each step. Alternatively, you could just simplify and reduce all at the end. You'll get the same answer. All right, so I have everything distributed, and now the only thing left to do on the numerator is to cancel things out. And the idea of this is I want to be able to get rid of this h. So probably all those constants are going to cancel. So everything that doesn't have an h is probably going to cancel. If it doesn't, I'm going to have a problem. So let's see, a cubed, there's a negative a cubed over here. So those cross out just like that positive and negative 1 did. So I'm looking for opposites. Next I have a 2a squared h. Let's see if I have another one of those. Well, I don't, but what I do have is a positive a squared h. So those are like terms. So they don't cancel, but I can bring them down and combine the like terms. And then next I have a h squared. And then I have a plus 2a h squared. So those also don't cancel, but that's okay because they have an h in them. So I'll just combine those like terms and write that down. Next I have the h cubed, only one of those. And then next I have a negative 3a squared, and I also have a positive 3a squared. So those like terms are opposites that cancel. And then I have a negative 6a h and a negative 3h squared. Neither of those cancel. And there's only one, so there's nothing to combine. So I'll just copy those down. So combine like terms and cancel what you can. And hopefully you'll get to a point where there's an h in every term, which means I would be able to take an h out and factor out an h. Even if I can factor out more, like a GCF, this is not about GCF. It's about factoring out an h because I want to cancel the h's in the denominator because it's causing a problem. And I can't take my limit as long as that h is in the denominator alone. So, but I can't take an h out of everything. So I can factor out an h out of this whole numerator since there's an h in every term, and I get 3a squared plus 3ah. It's okay that there's still an h in there. We just have to make sure we take out one, but it's still okay if there's other h's on the numerator because we can put in zeros for the numerator. All right. Now I can reduce. So now my h cancels, and I'm left with a polynomial in the numerator, and the denominator is gone. So I'm going to take the limit. I'm just going to reduce it one more time to rewrite this neatly. But now I can actually take the limit. I can actually take the limit now because the denominator, plugging in 0 for that denominator is gone. So I can plug in a 0 and I don't break any rules. It's just a polynomial now. So I'm going to plug in a 0 for each of those h's. And when I take the limit, I don't have to write the word limit anymore. So now I just rewrite this polynomial with a 0 for every h. Notice I still have the a's, and that's okay because remember we're writing a general equation. So we'll have a's in our final equation, but our h's are all gone. Our h's are now zeros. And then I'll simplify this, and I get 3a squared. And then this guy goes away because that's a 0. 0 times anything is 0. 0 squared is 0. I think I had a little typo here. I don't know where this 36 came from. That should be a 3h, which means that's a 0. So that one cancels as well. 3 times 0 is 0. And I have minus 6a. So this is my derivative in terms of a. I can also write this as a general equation as in terms of x. So f of x, the derivative of f of x, is 3x squared minus 6x, just substituting the x for the a. So this is the derivative. All right. Now let me ask you a question. Let's think about something. So my question is, why isn't that a line? Isn't the equation the derivative of a function a tangent line? So shouldn't it be in y equals mx plus b form? My answer would be no, not quite. It's the slope of the tangent line, not the actual tangent line itself. The derivative is the slope of a curve, or the tangent line, at a single point. So it's this tangent line slope, it's not the line itself. Which brings us to part B. In part B, we're going to find the equation of the tangent line to this curve. So one of these purple lines are the slope. We found the slope of it, or the equation for it, and now let's actually find what the equation of that line would be. So to find the equation of a line, I need a point, which I have as 2, -3, because I've been asked to find this, the tangent line at this point that goes to that point. So my point is 2, -3. And the other thing I need to make my equation of a line is the slope. And the slope is the derivative at the at the point. So here our x equals 2. So I take the derivative of f at 2. And the derivative of f, we found, is right here. So plugging in 2 for x, or for a, I get 3 times x squared minus 6 times x squared, and I plug in 2 for the x. So that gives me the slope of the tangent line equal to 3 times 2. I got to do my exponent first. So 2 squared is 4. 4 times 3 is 12. 6 times 2 is 12. And I get 0. A slope of 0. What does that mean? That's a horizontal line. Through that point to negative 3. So thinking back to what does that graph look like that we sketched in the top of this problem? At 2, negative 3, so that's, we actually have a horizontal line. The only way for a tangent to be a horizontal line is if it's at the bottom or the top of a curve. That's when you're walking flat. When you're walking uphill, you're going uphill. When you're walking downhill, your derivative is negative because you're walking downhill. Where do you walk flat? You walk flat at the top of a hill or at the bottom of a valley. So this is a horizontal line through the point 2, negative 3, which means our tangent line, the equation of a horizontal line is always in terms of y, because x could be anything on that red line. So it's always in terms of that y, that negative 3. So this equation is y equals negative 3. It's a horizontal tangent line. And from the graph, I can see it's a minimum. So a horizontal implies that this must be a maximum or a minimum. And from the graph, I can see it's a minimum. So in this problem, we got the curve, a cubic, and we found the derivative of that curve at any point. So that's my equation for the derivative of this curve. And then I used that to find the slope of a tangent line through a point and found the equation of that tangent line, which I think I forgot to write into my final answer. So the question asks us for finding the equation of the tangent line, which is y equals negative 3.